Now let us have an idea about the effective dose estimates for the CT CAT scanners and the cone beam CT. Of course, this varies. Here we can't give a number. It depends again on the exposure parameters. But a dose from the small and medium field of view ranges between 11 to around 675 or 4 microsieverts. Average is around 61 microsieverts. If you increase the field of view, then of course the exposure to the patient will increase consequently, and it will range between 30 to 1000 microsieverts. So it is the average is around 87 microsieverts. But the effective doses from conventional CT, that is the CAT scanners, is significantly higher, ranging from 1320 to 3300 of a mandibular scan, and 1000 let's say 1000 to 1004 microsievert for a maxillary scan. You know that the mandible is a thicker bone, so you need an increased dose. Of course, if you want the whole skull, the story is totally different. And if average background, the dose, if you go for the whole skull, it's over 2000 microsieverts, so the dose is higher. Knowing that we are the average, as we said in the protection, radiation protection videos, that we are depends on what we do, where we live. The average annual dose is 2,400 microsieverts. That is 2.6 microsievert, and our daily dose is 6.6, around 7 to 8 microsievert per day. So this is a comparison of doses between different views. Of course, cone beam CT, they have modalities that are unique to the maxillofacial imaging if you need it. Access and interaction with CAT scanners are not possible as a workstations is required. So in the cone beam CTs, since they are dedicated to the dental use, so we can say there are preset programs, softwares that enables the communication between a dentist and the machine. In the CAT scanner, this is not achievable. You have to have other systems that are enables the CAT scanners to be dentally oriented, we would say. It can be converted and imported on a personal computer like Simplan, Materialize, Lieben, all these. This process is expensive and requires an intermediate stage and can extend the diagnostic phase. But the reconstruction of the CBCT that is performed by a personal computer, any personal computer. The CBCT software can be made available to the user either via direct purchase or use license. It comes licensed, depends how much you pay actually. Companies can give you the whole package of software that enables you of doing all the programs that you need for dental use, dental surgical use. Chairside image quality, of course, display, real-time analysis, all these can be purchased on a computer. You can do your cursor-driven measurements with the clinician to do real-time measuring assessment. Actually, see, because the cone beam now is more dentally oriented and it is more serving specific needs, and actually I would say complicated needs. There are so many programs now and softwares like implants, diagnosis, planning implants, surgical guides, even correct guidance, 3D printing, like transferring the data to STL formats, and then you can print it on a 3D printer. The surgeons now, they are making use of pre-constructions of like wires on a 3D skull or a 3D mandible, so that they can formulate their whatever they want to use on a skull, like in cases of resection of tumors and these things. So you can pre-design your treatment on a printed skull, and then you can convey it directly on the patient during the operation. However, there is you see this starry appearance of on the this axial view. This actually is called image artifacts, which is called starring of the X-ray. This is a mishap that happens in the CAT scanners because this is because of the difference in the X-ray absorption coefficient. Especially in thicker views, you will end up with this. Fortunately, in the CBCT scanners, the starring effect is less, and it is getting less by more refining of the image. So CBCT can result in a lower volume or level of metal artifacts, especially in dentistry. There are lots of metals in the like crowns, implants, amalgam fillings, name it. So these, if you take a CAT scanner and then take another cone beam CT, you will find that the metal artifacts are less in the CBCT. This is because of the lesser amount of tissues that are being scanned. Okay, as we said that not every imaging machine is imaging technique is the ideal one. There are lots of every system has its advantages and disadvantages. Now, the two important disadvantages of the cone beam imaging CBCT is that it has very limited ability to display the soft tissues. Unfortunately, if you want to display the soft tissues, you have you have two options. Either you send your patient to do an MRI imaging, which is the ultimate in showing the soft tissues, or you go for a CT. And the CT, this is on the expense of a higher dose, as we discussed earlier. But in the cone beam, no, you have only the ability to have the hard structures. Of course, there are not all software is capable of 3D color display. This is image rendering, 3D image rendering. This is again depends on the software. Now, machines are getting better and better always. You can go further for the cone beam imaging on this reference, and there are many references in the literature. Now, too much is being the CBCT actually is being overwhelmingly discussed in the literature. Thank you very much.